Okay, we are on video 2.12. This video is on residuals. We're working more with scatter plots, and you're going to see what a residual is as we move along and how it can help us make accurate predictions on our data. So the first thing you need to know is what a residual is. It is the deviation. We know that deviation means distance of a data point from the predicted value, or once we get them all together, it can be the prediction value. So how you find the residual is much like you find deviations with our standard deviation tables. Take the actual value and you subtract the predicted value. Make sure you get that down in your notes. So the first thing we're going to look at before going into residuals is how to use a function to make predictions. So in the work that you're going to do tomorrow in class, you're going to be given an equation, which is a line that should fit all the data that's in the table. It's called the line of best fit, and as you go into the residuals, it'll be called the least squares line, but for now I'm going to call it the line of best fit. And you are given this equation. You don't have to come up with it yourself yet. You're also given a table of values that are now plotted on this scatter plot of shoe length versus men's heights. So men's shoe length and then their height. So let's just answer these two questions using this equation for the line. We can use this equation to answer these questions about predictions. We don't have to just look at the graph and guess what the answer would be. We can actually calculate it. And we do that by substitution. So I see that my y value is height and my x value is shoe length. That's what I was measuring. That was my independent value, and my height was my dependent value. So would you predict the height of someone to be with a shoe length of 13? So I have my x, it's 13, but I don't have my y. That's what I'm going to look for. So I'm going to use this equation that we're given, which matches the scatter plot. And we'll say y equals 25.3 plus 3.66 times 13, my shoe length. X is my shoe length. I'm going to plug it in. And when we solve this, we get y equals 72.88. So you can predict that someone with a shoe length of 13 would be about 72.88 inches tall. Using a very similar process, when we need to find the shoe length, now we're being asked for the shoe length of someone who is 72 inches tall. We are now given our height, which is our y value. So I'm going to plug 72 in for y, and then we just keep rewriting the equation, and we're going to need to solve for x. So I need to take away 25.3 from both sides, and I get 46.7 equals 3.66x, and then when I divide both sides by 3.66, I get x equals 12.75. So I can predict that someone who is 72 inches tall would have a shoe length of about 12.75 or 13. Now, this makes sense because if you look at our two predicted values that we found, for someone who has a shoe length of 13, that would be about 72.88 inches tall, and for someone who's just 72 inches tall, it's just a little less at 12.75. So this question is asking us to calculate residuals, and remember, residuals are the prediction value. We're going to get into a lot more how these can apply to making our own line of best fit or least squares line tomorrow, and we're going to see a lot more how they can be applicable to making predictions in data. But for now, we're just going to learn how to calculate them and see how good of an equation we have here that matches our data. Because remember, for scatter plots, sometimes they can have a really strong correlation, which means it's a really accurate prediction. But if it's a very loose correlation, it may not be such a good predictor of our data values. So with residuals, you're always doing the predicted value with your y values. You're not going to do it with your x values. You're going to do it with your dependent variable. So remember that residual is the residual is going to equal the actual y value minus the predicted y value. So we are asked to find the residual of the height for someone with a shoe length of 12.6 inches and 74 inches tall. That's this first guy in the data set right here. So our actual measured height is 74, but we need to find out by using this equation what our predicted value would be first. So I'm going to take the shoe length of 12.6 and plug it into my equation to find out what the predicted height would be. So we have y equals 25.3 plus 3.66 times my shoe length of 12.6. And based on my equation, the height of someone with a shoe length of 12.6 should be 71.42 inches tall. So now let's go into the residual. We have the residual equals the actual y value, which is my measured 74 inches, minus my predicted y value, which I just found of 71.42. So my residual equals 2.58. Now this is our predicted prediction error, prediction value for this data set that we have. And we're going to go more into in our next lesson of how these can help us build our own equation for a prediction line. But for now, this is all you need to know how to calculate is the residual here. And note that it represents the distance from the actual value and the predicted value. And your hot question, from the table in the previous slide, I want you to use that same equation of y equals 25.3 plus 3.66x to find the residual value of a person who is 65 inches tall and has a shoe length of 11.4. So remember that 65 inches is going to be your actual value, and you need to use the equation to find the predicted height and then find the residual.